Hello, my name is Isabella. I'm a participant on this year's LIYSF, and we're here with Professor Sir Steven Cowley coming all the way from Princeton to join us today. I'm very excited to hear his insight, so let's get started. My first question to you would be, what first sparked your passion for plasma physics and the pursuit of fusion energy?
Well, I was driving to school one day with my dad. My dad was a professor of engineering at Cambridge, and I think he was trying to find something to talk to his child about. And so he told me about fusion. And I thought, wow, that is kind of cool, right? And, you know, it's an amazing thing to imagine that we might make energy the same way that sun does. So I think I was about 15 or 16 at the time. And so I think it kind of spurred me on to study a little harder.
That's a great way to connect with your family and pursue what you love. The next question is, nuclear fusion has been called the ultimate clean power source, but it remains incredibly difficult to achieve. What do you think is the greatest scientific or engineering barrier that we still need to overcome?
Well, you see, I think we can do fusion. The real question is, can we do fusion at a cost you want to pay for your electricity, right? Because if it costs too much, why do it, right?
Yeah.
And so at the moment, when we do fusion, we have to make enormous machines that are very expensive because we have to keep the fusion fuel at about 200 million degrees. And the way we do that is by putting layers and layers of magnetic field on top to stop the heat leaking out. And at the moment, we have to put so many layers to stop the heat leaking out that it makes it very big. Now, what we're trying to do now, and particularly with the use of artificial intelligence, is to find smarter ways to hold the heat in with the magnetic field so that we can make it smaller, cheaper, faster, and therefore get to market.
That's very interesting. I hope that we could advance and develop this soon. And next question would be, how close do you think we truly are to making fusion energy practical and part of everyday life?
Well, so the US government has put out a goal basically, and that is that we get some fusion electricity by the end of the 2030s. So it'll be within my lifetime, but not perhaps as soon as I had wished, right?
Yeah.
It's harder than we thought because people started thinking about doing fusion just after the Second World War. And it's taken us a long time to get this far. But when we know how to do fusion, we'll never not know how to do fusion. Right?
Yeah.
That'll be it. That'll be the moment in which the whole world changes to using fusion as a power source.
Okay. And what advice would you give to young scientists who want to contribute to solving complex global challenges like energy and climate change?
Well, you know, study and study some more. You know, the people can do amazing things when they enjoy what they're doing. So if you enjoy doing science, right, you can do amazing things. So find things that make you excited. Find things that make you happy, right? And I once joked, and my son told me I was a nerd to say this, but I once joked that doing physics was more fun than playing Sudoku. And it's a whole lot more fun.
Okay. Thank you so much for all your insight. It was a pleasure to be with you here today and hear everything that you had to say. It was great meeting you.
Well, and you too, Isabel. Thank you very much.
Thank you.